Hello, I'm going to be going through H44602 the OCR 2021 Algorithm and Programming Exam question 1CII, in which we are tracing the A-star algorithm through a given graph. Okay, so we start off from A and we're working our way to G, and we're using the A-star algorithm. So the first part is to define a heuristic, and we said that was a metric that we use to make an estimate of the distance from a current node to the goal state. So as an example, on a physical map, you could work out the actual physical distance between the two spots, and this helps guide the algorithm in the right direction by prioritizing nodes that we estimate are going to be better. As an example, on a physical map, you could say that we can guide ourselves in the right direction, for example. And you can see on the map that the heuristic actually decreases as we get closer to our goal state. Okay. So first of all, let's fill in our first node. So that's A, and this is all quite simple. So the distance travelled, we're saying that the distance from the beginning to our current node, right? So it's going to be 0 at the beginning. And obviously there are multiple paths we can take. So in this case, we'll use this previous node to determine which path we took, and we can follow it backwards. So 0, heuristic of 90, and the sum of the distance travelled plus the heuristic, which is 90. Okay. Right, so in terms of choosing where to go next, so let's have a look at our two options. So we have explored A, because now we've unlocked the nodes B and C, which are our two options. So let's fill in those. So we have options B and option C. Okay, so if the distance travelled with B, so we're saying that the distance from the beginning, which is A, all the way up until B, so that's just 21. The heuristic of B is 80. So our total distance is going to be 101. We do the same for C, so we have 42, 65, and then 107. And the previous node is A for both of these. Right. Now the frontier has opened further because now we have both D and E which can be explored. And note that D can be explored either through B or through C. So we're going to explore B because we look at the 101, the 107, so the 101 is lower. We ignore A, in this case even though it's lower, because we can say that we have explored it fully, right? We're not going to go back to it, so let's tick it off to show that. B and C are the only ones we're considering now. So, we're going to explore B first. So we can see a B unlocks D and E. And this doesn't necessarily mean it will go A, B, D. It's possible that C will be better, and we'll find that out later when we explore C. So, we go A to B, and that's just look in alphabetical order. It doesn't really matter. We evaluate them all and find out which is the best. Okay, so D. So we sum up the total distances. So we have 59 and a heuristic of 50. That gives us 109. Okay, and that was after B. Now for E, we have a total distance of 61. So we follow the 21 and then the 40. A heuristic of 50. So we have 111 as our sum. Right. So we can now tick off B, because now we've explored D and E. Now looking at C, D and E, we look for the lowest. So we see that the lowest is exploring through C, which has a sum of 107. Now, when looking at C, we have another path which is to D. So we go A to C to D, and that's the only one that opens up. So we can try this. Let's have a look at the result for that. So if we go through A to C to D, we see that we have a distance of 42 plus 12, so we have 64. However, 54, sorry. However, if we go from A to B to D, we can see that the distance is 59. So that means that we actually have it's actually a better route to go through from A to C to D than A to B to D. So now that we've found that, what we can do is we can get rid of the previous approach, that A to B to D, and replace it with A to C to D. Because we can say there's absolutely no reason to go through that if there's a better route to go to D. Now, this again may not be the correct route, but we know that if we go to D, we will always choose A to C to D, not A to B to D. So we can definitively cross that off. So, in the mark scheme, they actually just write it on the same row. But I'm just going to cross this off like this, and then write it on a new line, just because I don't run out of space. Okay, so we say D, and then this is after C. And so I need to put B here. Okay, so D goes to C. C goes to D. Sorry. So we have a total distance of 52, a heuristic of 50, and a total of 102. Okay, excellent. Oh, sorry. My mistake. That should be 4, not 2. 54 and 104. Okay. Right. So now we can say that we have explored C. This is no longer in our frontier or in our list of nodes to look at. So we check that off. Okay, so now we just have the options E and D, and D is done through A to C to D, and E is done through A to B to E. Okay, so we have 111 versus 104, so clearly we should do the C to D first, because it has a lower sum of distance plus heuristic of 104 versus 111. So, looking at D, there's only one place we can explore, and that's F, so let's write that down. So, F, we have a total distance of, so we can add them all together, but the easiest way to do it is, okay, we do 23 plus the total of the previous distances, so we have 77. Okay. Then the heuristic of F is 30, and we sum them together to get 107. Okay, and now D has been fully explored. We have added all of the possible nodes after D. Okay, now we can either choose to explore either E or F. So F has the lowest heuristic of 107 versus 111. So explore F. So the lowest sum of heuristic and distance of 107. So we see that, okay, F, we have G. We have 33. Actually, sorry, not 33. We are summing the distances. So we take the previous one. We do 33 plus the total up until F. So we have 110. Yep. Heuristic of 0, we have 110. And let's just cross off our F. Yeah, okay. So we can stop here. We actually haven't necessarily finished, in the sense that E is still not ticked off. We could have explored E to G, but we have found our solution, so we stop here. Okay, and let's just fiddle in the results that we have F here. Okay, so now we have to, the question asks, let's go down here, find the shortest path from the starting to end node. Okay, so we're looking for the path that we went through as well as the distance. Okay, so so we can go backwards. So we have G, then we went, that was from F. Okay, how do we get to F? We've got to F through D. How do we get to D? We got to D through C. How do we get to C? We got C through A. Okay, so this was A to C, to D, to F to G. And we summed the distance, so we can see that it is 110, yeah. Cool. And that's all there is to it. So I think the main thing to mention here is that when we crossed out the B to D and replaced it with the C to D, we weren't looking at the sum of the heuristic plus the distance travelled. We were just looking at the distance travelled. So we saw that the 54 was lower than 59, and that's what we're focusing on here. Yeah. So we're trying to optimize the distance. Okay. Cool. So I hope this helps. This is the full graph. Note that it's intentional that E is not ticked off because we haven't actually explored it. But we'll stop as soon as we get to an answer.